Bonjour tout le monde. Nous allons attendre une couple de minutes ou une minute ou deux encore pour laisser tout le monde se joindre et on va commencer. Hi, everybody. We'll just wait a few or one minute more maybe before we start to make sure everybody's joined properly. Kazim, I think maybe we can maybe go ahead if you want to go to the next slide.
Absolutely.
All right, thank you. I'll speak a few words in French to begin with, and then I'll switch over to French for everybody who's joined. Bon matin à tous nos invités, collègues de Citron et à Kazim, et surtout Kazim et Dan. Comme décrit dans le courriel d'invitation, cette rencontre se tiendra en anglais. Nous avons la chance de vous présenter un nouveau service et la chance d'avoir des fabricants ici pour en discuter et pour répondre à vos questions. Par respect à eux, je vais maintenant continuer en anglais, mais à la suite de la présentation, on vous donnera la chance de poser des questions et je peux traduire en anglais pour ceux qui préfèrent les poser en français. Vous pouvez tout au long de la présentation écrire dans le chatter vos questions et à la fin, nous allons tous essayer de répondre à toutes vos questions. Merci encore d'être présents et je vais maintenant changer en anglais. Good morning and a warm welcome to all of you for joining this webinar. My name is Bernard Brodeur and I'm the General Manager for Citron Hygiene in Quebec. As a global leader in facility hygiene, we at Citron Hygiene are in constant pursuit of innovation and technologies to enhance and improve our service and product offerings. One key gap we noted in our assortment was air sanitation, and something that's been in the news a lot lately. And for the past many months, we've been working with numerous global vendors as we explored the category. We are excited to share with all of you today what we have chosen from SaniZone Scientific International, the details of our new air and surface sanitizing product designed for common areas, notably washrooms. We see a need to provide enhanced disinfection in the air and on surfaces in light of COVID-19. Building owners and managers want to provide the highest level of safety to tenants, and tenants want to feel their work environments are safe. On the call today are representatives from a variety of industries, manufacturing, retail, real estate, and the hotel industry, to name a few, and we are very grateful for your time today. As time is of the essence, let me get right into the introductions. Joining us from England is Kasim Arshad, and I'm sorry if I mispronounced that, Kasim. No. Sales and Marketing Director from SaniZone Scientific International. Kazim will take us through a high-level overview of the product. Along with Kazim, today is Dan Slopak, who is the North American Business Development Manager from SaniZone Scientific International, who is joining us from the Northeast US. Welcome, guys. The purpose of this webinar is to give each of you a flavor of the system and how it potentially could aid your back-to-work programs in your buildings. To the extent it can, we would be delighted to branch off with those interested for more concrete discussions with respect to your individual portfolios. Just a quick housekeeping item is that we have reserved time at the end of the presentation for Q&A. So if you have any questions you would like to address, please type in the chat and we will address them at the end of the presentation. We've allotted half an hour. Well, really we have an hour in the time slot, but the presentation will probably take about 25 minutes. And so we left ample time to ask questions at the end. Kazim and Dan have offered to stay on the line if anyone would like to ask more questions or dive deeper. So with that in mind, I hand it over to Kazim.
Thank you, Bernard. Thank you for the kind words and kind introduction. Bonjour, everybody. And thank you for taking the time out this morning to hear us out. As Bernard mentioned, there's quite a bit of information for us to go through, so please do bear with me. Hopefully we'll have some time at the end for questions. And so let's get right to it. Okay. I wanted to give you all a very quick overview of the business, who we are and what we do. So obviously myself, Kasim, I'm the Sales Marketing Director here in the EMEA region, so Europe, Middle East, Africa. And we've also got my colleague Dan Slopak on the call. Dan is the Business Development Manager for the Northeast US and Canada regions as well. Established in 2006, we've got a global HQ in Orlando, Florida in the States, but we also have offices here in London in the UK, We also have a distribution hub in Finland to service our EMEA region in Europe. And we also have a Asia Pacific region run out of Hong Kong and Shenzhen offices in China. So fully global reach, if you like, as a business. In terms of who we are and what we do, well, we are a market-leading global business that provide UV and plasma-based disinfection solutions. That is what we do. We service three main industries. First being HVAC. We provide advanced UV systems for HVAC systems to be able to treat airflow passing through commercial buildings. Very recently, we signed a very large global deal with the largest cruise line operator in the world, Carnival Cruise Lines, to deck out their entire fleet of ships with our UV systems to be able to keep passengers and staff on board safe. With the food services side, we have two main products. One is called SaniZone. It's basically an ice machine disinfection system. So we work with some of the largest ice machine manufacturers in the world, such as Hoshizaki, Isomatic, Manitowoc, Scotsman. Some of these names may be familiar with you. And in turn, therefore, we work with some of the largest fast food chains in the world, such as your Subways, Chick-fil-A's, Burger King, etc., etc. The other food services product that we have actually is a high-powered UV system, which we install into commercial kitchen hoods. So commercial kitchen hoods, as you know, over time will accumulate grease, not only in the hood itself, but the associated ductwork, which A, is a pain to clean and very expensive, of course, but B, it also poses a fire risk. What we do, therefore, by installing high-powered UV systems into the kitchen hood is we remove all of the grease, therefore removing the need to ever clean the hood again and the associated ductwork, of course, but it's also a fire reduction risk as well. So fantastic solution there. But the product that I want to talk to you about today is from our hygiene division. Our hygiene division is our largest division globally. It's the BioZone Air Care or AC system. All of our solutions provide an element of air and surface disinfection through preventative maintenance systems. They are all very low cost, very low energy to run, and therefore they are energy efficient. They provide an element of automated cleaning and with an added side benefit actually of odor control. Just a key fact for you all, we are the largest user of UV lamps as a business in the world. So we go through quite a few of them. And with this particular product, the BioZone AC system or the SaniZone, we are market leaders in the hygiene sector. So we like to work with market leaders in the respective restroom and hygiene market, hence the reason why we're so happy to have Citron Hygiene on board as our key North American partner. Just a snapshot of some of the case studies and clientele that we have all over the world. I'm sure you recognize some of the names on this list for sure. So the product that I want to talk to you about, the BioZone Air Care system, aka the SaniZone system, we have an unofficial mantra here at BioZone. It's basically bad stuff in, good stuff out. There is more to how the system works, and I shall explain that shortly, but that is the crux of what this unit and this technology is capable of doing. This particular product is our best-selling line globally, and what we do is we don't actually sell this product to end user sites directly. We sell them through distributing partners such as the likes of Citron Hygiene. So although we don't get full visibility of where these units actually end up, what we do know is that we've got tens and tens and tens of thousands of installations all over the world. Some of those key fancy examples, if I may, include the likes of Heathrow Airport, Orlando, Dubai, Hong Kong airports as well. We've got commercial buildings in here, such as Barclays Capital. We've got various shopping centers around the world, including the Raffles in Singapore. And we've also got the various metro systems as well, such as the Shenzhen metro system in China as well. Just to delve a little bit deeper into some of these case studies, Barclays Capital, a very big old commercial building in the UK, 96 washrooms in this building alone. At the time, the FM company that was looking after the building itself received constant customer complaints for bad odors and poor sanitation. What they tried to do was put more people to work, increase cleaning frequencies, etc. but the steps weren't enough and the account was about to be terminated. After installing our units, pretty much overnight, the results were amazing. The complaints were gone. The client was happy. And what the FM company actually reported back was that they were able to reduce the cleaning frequency time by about 75%. So we were actually saving them money in the end, which is a fantastic result. I'm sure you'll agree. Another one of our key case studies, Heathrow Airport, as you know, one of the busiest in the world. Over 35,000 people a day using these restrooms, these washrooms alone. So as you can imagine, severe odor issues, chronic sanitation problems. And what they did, or what they tried to do to overcome this, is what we usually find sites try to adopt this measure of literally trying to bombard the area with as much fragrance dispensers as possible. Obviously, as we know, this doesn't actually get rid of the problem. It's simply trying to mask the issue. However, after installing our units, again, the problem was gone, and it was actually the first time that they were able to meet the BAA local washroom sanitation standards. So really, really good set of results again, as far as we're concerned. So Biozone AC, SaniZone, what we feel the solution is. What we do is we use in our technology a purifying gaseous form of disinfection called photoplasma. Okay. Now, because this is in a gaseous form, and I'll explain how it works and how it's generated in just a short while. Because it's a gas, it fills a space, and therefore it's able to reach the places that no other manual cleaning technologies can. Which gives us a distinct advantage over other technologies in the market. Because of that, we've got the ability to eliminate bacteria, fungus, viruses in both the air and on surfaces. Okay. Obviously, since the COVID pandemic, you must have heard of technologies out there that are either using, either a HEPA-based form of HEPA-based form of trapping airborne contaminants, or surface disinfectant sprays which are treating surfaces, but they're only doing one. They're either doing the air or they're doing surfaces. The great advantage that we have with our technology is that we treat both. So we treat airborne contamination, but we also treat surfaces as well, which is a fantastic plus point as far as we're concerned. These units, this technology is completely chemical free. So we don't use any chemicals whatsoever in the procedure. So if sites are using urinal blocks, deodorizer sprays, chemical floor cleaners, etc., we don't contribute to the overall chemical usage because we are completely chemical free. So that's another tick, if you like, in the box. These units are designed to operate 24 hours a day, 7 days a week. So they clean the air and surfaces continuously. Now, you may be wondering, in order to conserve energy, why can you not just switch the units off? If you're the last person on site, for example, and then switch them back on again first thing in the morning. The reason behind that is it's actually counterproductive to switch these units off because if you can imagine, bacteria, unfortunately, don't stop growing. So if you were to switch the units off and then come back in again the next morning to switch them back on, you may find that odors have returned. And that's because bacteria have been allowed to multiply continuously overnight. But secondly, these units actually cost less than a low energy light bulb to keep on. So they are very, very cost effective indeed, and very, very low energy indeed. A Citron certified technician is required to change out the UV lamp on a predetermined service frequency. So they are very, very minimal maintenance indeed. And finally, the area not only smells fresh and clean, it really is, because it's because we're treating the bacteria and the contamination which causes odor to begin with. Okay. However, just a quick point to note that these units are not designed to replace any cleaning mechanism that you may already be adopting on site. We are an enhancement. Okay. What we are saying is that by introducing our units, but also continuing to clean, continuing to wash hands, sanitize, wearing of face masks, social distancing measures, etc., that we are taking the absolute best form of defense possible. Okay, so how does it work? Well, this is the simplistic diagram to showcase how it works. I mentioned earlier, you've got bad stuff in, it comes in here, it's exposed to a UV light source, and it comes out the other end lovely and fresh. There is more to it, however, and I shall explain just now. So we work on a two-step disinfection process, okay? The first step is that we have airborne contamination which enters into the chamber of the unit. It is exposed to a UV light source which will basically disinfect anything that it comes into sight with, and it comes out the other end lovely and fresh. So the first step is the treatment of the air using the UV light source. Now, I'm not sure how much you know about ultraviolet light, but ultraviolet light is split into certain categorizations dependent on the wavelength bracket within which it sits. Okay, so ultraviolet light is measured in nanometers. That is what the NM stands for. And you have UVA, which you may be familiar with, UVB, but also UVC, which is otherwise referred to as germicidal light. And the reason it's referred to as germicidal light is because it is the most effective at being able to eliminate bacteria, viruses, and other contamination. There is actually a peak level of germicidal efficiency, which sits at 264 nanometers. Okay, that's 264 nanometers as being the absolute optimal level of disinfection. Now, our lamps, they operate at 254 nanometers, so 10 nanometers less, if you like. And you may be wondering why. Why do you use 10 nanometers less if the peak is 264? The reason is twofold. The first is cost, okay? If the units themselves, the cost element, the units wouldn't be the price that they are if we were using lamps that operated at 264 nanometers. Let's put it that way. The second reason is the fact that these lamps are very, very difficult to mass produce at that optimal level of 264 nanometer. Okay, so as I mentioned earlier, we are the largest user of UV lamps as a business in the world, and therefore we go through quite a few of them. But if you're wondering what the difference is between the two, i.e. 254 and 264, they both sit in the 99th percentile of disinfection rate. So we're talking minute differences. And in fact, everybody who uses UV will use 254 nanometers as an industry standard, okay? So that's the UV element. But where we differ from other technologies on the market that do potentially use UV is through the generation of a substance we call photoplasma. Now, why do we generate photoplasma? The reason is that we can't expect all of the air within a space to pass through a tiny unit, a tiny fan like this in a washroom or another transient area. It's simply not possible. So if you do hear of other technologies on the market that are claiming to force all of the air within a space through a tiny unit, I can tell you now it's feasibly not possible. So we need to rely on a secondary form of disinfection, and that is through the generation of the substance we refer to as photoplasma. What is photoplasma and how is it generated? Well, very simply, what we do is we take the air that comes into the chamber and we charge it up using UV. That's all we're doing. We're taking the O2, the oxygen, and the water particulates, H2O, from the air, and we charge them up using UV. What we create as part of this reaction inside this chamber is a highly reactive, energized mix of air that we refer to as photoplasma. Now, one of the key components of photoplasma is a substance called ozone. You may be familiar with. Ozone is basically O3. It's oxygen, O2, that is charged up with an extra O, a monomolecular O, that attaches itself to oxygen, charges it up, and it creates ozone. Ozone is found naturally in our atmosphere. It's often referred to as nature's most powerful disinfectant, but it has the ability to eliminate bacteria, viruses, and other microorganisms. What this unit also has is a negative ion generator inside the chamber. This is continuously producing negative ions. And negative ions, all they simply do as part of this process is when they are released from the other end of the unit, they latch onto airborne impurities, making them heavier so that they sink to a surface, sink to the floor, and therefore become easier to clean. Okay. But the key ingredient of photoplasma is a substance we refer to as hydroxyl-free radicals, otherwise known as OH molecules. Now, these hydroxyl-free radicals, when they are released from the other end of the unit, anything that they come into contact with, both in the air and when they land on surfaces, they disinfect and clean. Okay. The great thing about them, though, is that they effectively act as suicide molecules. So they latch onto impurities in the air and on surfaces. They break them down, they disinfect and clean them. And once they've done their job, they simply revert back to their natural state of oxygen, O2, and water particulates in the air. There is no residue left whatsoever from these units. And that's what makes it such a green, clean, and effective way of air and surface disinfection. So I hope that was clear, but I can answer additional questions at the end if there were any questions on that specifically. So I'll move on to very quickly the testing phase of our technology. Now, before I explain what these test results actually mean, I want to take a step back, if I may, and explain very quickly the fact that UVC, ultraviolet light, is not disputed in terms of its ability to be able to kill a range of bacteria, viruses, fungi, and other microorganisms. In fact, prior to COVID, UVC was already proven effective against other coronaviruses such as MERS and SARS. Okay, so the test results that you can see in front of you now are not relating to UVC, they're relating to photoplasma because that is ours. That is what we need to prove in order to, its efficacy in terms of how effective it is. Okay, so this set of results you can see in front of you is measuring surface bacteria. So you can see whether it's Listeria, E. coli, the effects are the same, that after as little as a minute's worth of treatment, we are in the high 99th percentile rate of disinfection. After 2 minutes, we bump it up by a couple of decimal points. And after 24 hours worth of use, there was no remaining bacteria whatsoever in the lab, which is a fantastic set of results. Surface bacteria is actually notoriously more difficult to disinfect and break down because I'm not a scientist, by the way, but you can imagine it's layer upon layer upon layer upon layer of cells that we have to break through and break down. Okay. Well, how effective is this technology against airborne viruses? And I'm pleased to report that it's actually even better. The results are even stronger. Back in 2009, there was an outbreak of the avian flu virus, otherwise known as bird flu, but more commonly known by its scientific name as the H5N1 virus, which you may be familiar with. Now, there was a series of tests that were performed at the CNRS. The CNRS is the French National Laboratory, but it's also a World Health Organization accredited laboratory and a collaborative center for avian and human flu viruses. Okay. What they did was they tested BioZone technology, plasma technology, against the virus, and what they found was that we were able to achieve a 99.9998% disinfection level in less than 0.44 seconds. That's a fantastic set of results. Really, really strong data there. Now, whilst it's great doing it in a lab, of course, field testing is something completely different. So we've obviously conducted test studies against that. We did a test study, case study at the University College of Dublin. This was conducted in a large student lecture auditorium. As you can imagine, students aren't the cleanest of people at the best of times, but coughing, sneezing, spluttering everywhere. Samples were taken before and after, and what we found was that we achieved an average of a 70% reduction in both surface and airborne contamination, and that's in a real life setting. So we're not just treating surfaces, we're not just treating airborne contamination, we're doing both. And we achieved an average of a 70% reduction, which is a fantastic set of results. But it only just goes back to my earlier point that we are an enhancement to this to cleaning measures. Okay, we are not the be all and end all solution. We don't claim to be, but what we are saying is that if you introduce our technology and you continue to clean and you continue to do everything else that we're supposed to do, we are providing the best form of defense possible. That is categorical. So more exciting news, of course, COVID results. I'm pleased to inform you all that just before Christmas, of 2020, we published the first set of data that we received. I don't know if you could see this, sorry, I don't know if this is getting in the way, but what this says is breaking news, BioZone UVC lamps kill COVID. So as I mentioned earlier, we've got a two-step disinfection process. The first is ultraviolet light, UVC, and the second is photoplasma. We decided to test the UVC lamps first, and the results came back to be fantastic. This is just a couple of quotes from my line manager, Paul, but also the CEO of the business, Ari, in terms of what these results actually mean for us. But if I do delve a little bit deeper and explain what these results mean, first things first, as I mentioned earlier, UVC had already been proven effective against MERS, SARS, and a range of other bacteria and viruses. It wasn't disputed. Prior to us having tested our own lamps against COVID material, UVC was also proven against COVID as well. However, our clients, our partners would always ask, have you guys tested your lamps against COVID material? And we didn't have that answer before, but we do now. And what it shows us and what our test results show us is that in as little as 0.25 seconds, we're able to achieve a 99.1% disinfection rate on COVID material, whereas some of our closest competitors who also use UV take up to 2 seconds. Now, I know that doesn't sound like a big time difference, 0.25 seconds to 2 seconds. It's over in the blink of an eye. However, if you look at it from a scientific perspective, these results are absolutely poles apart. Okay, because what you've got to bear in mind as well is, contact time, speed of airflow, UV irradiance levels, etc., etc. All of these factors play a part. What it tells us basically is that our lamps are of a very, very good quality indeed in comparison to others on the market. What it means for our tech, however, is that what we can now categorically say is that if there's airborne contaminants and they pass into our units, they're exposed to our UVC lamps, they will be disinfected even if it contains COVID material. So that's a fantastic set of results. It's good stuff, but it's only half the story as far as we're concerned. This slide is slightly old. This point is slightly old. I'm pleased to report that the photoplasma element of our testing has now been completed, and we are just days away, in fact, from releasing the test results and publishing the test results. I've been informed that the test results are very, very good. But that was the second element of our COVID testing, which we were hoping to get out by the end of March. It's running slightly delayed, so apologies for that. But we're hoping to publish those results in the next couple of days. And of course, we'll share the findings with both Citra and Hygiene, who will then, of course, share it on with yourselves. The key message here is the fact that our technology is, we believe, and will be proven effective against COVID-19. Absolutely. That's the good thing to come out of this testing. Okay, ozone, is it safe? Right. This is probably the question that we get asked most often. Now, ozone, in terms of explaining how safe it is in comparison to the amounts that we produce, this is the example that we give to try and quantify this, okay? So if you were to step outside in any major city on a warm summer's day, you will naturally be exposed to around about 0.07 ppms. That's parts per million, and that's how ozone is measured as a concentration, okay? In terms of the BioZone system, this unit is only designed to produce a maximum level of 0.05 ppms in a lab test environment. So what we're saying is that if you stick your head in a box with the unit on in a lab, you're actually safer with that than you are by being outside on a warm summer's day, just to try and quantify this for you, okay? But if you take it outside of a lab test environment and you site it in a real life setting, because of obviously the bigger area, the more airflow, et cetera, and the other variables involved, it's actually closer to 0.01 or 0.02 ppms in a live setting. So is it safe? Absolutely, yes, it is. Not only do we abide by OSHA guidelines in terms of North American guidelines, but we also abide by EU regulations here in Europe, which govern the maximum levels of ozone exposure within an indoor environment. This just goes on to explain a little bit further detail about the ozone concentrations. But the main message is, are we safe? Yes, we are, is the answer. And we are certified to that degree as well. Very, very quickly then, just to finish off the last few slides, if I may. The unit itself is completely generic, okay? But we have 3 official models, 4 unofficial models, if you like, ranging from the AC05, AC10, AC20, AC30. The AC05 being the least strength model, but because of its area coverage or its limited area coverage, it has limited uses, if I'm going to be honest. So if you were looking at siting these units potentially into elevators or lifts, then the AC05 would be applicable. But anything above that in terms of an area coverage, you're probably looking at an AC10 or a 20 or a 30. Now, the scale that you see in front of you is what we use to determine for washrooms specifically and washrooms only. We do have another sizing chart which covers area coverages in meters squared, but because of the time constraints on this call, that's something we can delve into at a later time. But basically, if you're looking to site these units in a washroom setting, for example, we use this odor source scale. So we simply walk around and we count the number of odor sources. So either one WC being an odor source or one urinal as being an odor source. And we simply go and count the total, and based on the total, we would determine which model of unit that you need. If, of course, you need more than 8 odor sources, it's a combination of units to get the right balance in a particularly large site. The units themselves are completely the same size, they're completely generic, the size, specification, everything is the same. The only thing that differs is the output of the lamp. Okay. In terms of where you'd place these units, so you'd want to site it, obviously, of course, as near to the problem area or the odor sources if it's a washroom as possible. But at the same time, what we want to try and do is site these away from any extraction hoods, vents, or open windows, because what we don't want to do is to allow the photoplasma to actually escape through these open hoods, vents, or open windows. And if it's sited relatively near to the influx of air into the area, that's always a good point to note as well. In case you're wondering what these symbols are on the right-hand side, this is just to show the level of certification we have on this product. You may be familiar with SGS. SGS is a world-leading authoritative body on testing protocol. We have SGS certification. We also have ETL Intertech certification for North America as well. And finally, just to give you a couple of examples on what these could look like. The example on the left-hand side, you've got 3 odor sources based on what we just discussed. There are 3 extraction points, so you want to keep the units away from there. Here is the influx of air into the area, and therefore you'd be looking at an AC10 unit for the example on the left. The example on the right, similar sort of setup, has extraction vents here, has more than 3 odor sources, but less than 6. So you'd be looking at an AC20 for this example here. And in case you were wondering what the unit looks like, the unit looks a little bit like this. Very, very simple design. You've got a fan, which is drawing air through the unit. You've got a UV light source. You've got a series of power drivers, etc. But you've also got a state-of-the-art locking mechanism on this unit, which makes these units completely vandal proof. I would challenge anybody to try and take these off the wall. You cannot do so without a specialized key, and the only person with access to the key would be a site manager or a Citron representative. I have no idea if I went over on time, so my apologies, ladies and gents, if I did. And I open the floor to questions. Thank you very much.
Well, thank you, Kasim, for that presentation, and attendees again for your time. The key goal we wanted to achieve today was to give you all a first view of the product that we are really excited to be bringing into North America, especially at this time, as it will address anxiety people may have about transmission risks in public spaces and help our building customers add to their own best-in-class return to work preparedness programs. Now, we can get to some questions now. There's one in the chat. I'll read that one for you, Kazim. So yep. The units can be installed in areas where people are working all day and not be an irritant. That was with respect to when you were talking about the ozone quantities. That's when this question came up.
Okay, very good question. To answer that question in the briefest and best way possible, the amounts of ozone that we produce are minute. Okay, they are very, very small indeed. However, because of the fact that these units do produce ozone, and in case anybody's wondering, this is not an unintentional byproduct. This is a fully intentional byproduct on our part because we use ozone as an active cleaning ingredient in what we do. Okay. However, the small, minute risk that is involved with affecting 1 in every 10, 20, 100 people, whatever it is, that may complain of a small headache, a small migraine, or whatever it is, due to the unit being sat directly underneath the unit. That is why we recommend that these units be sited in transient areas only. And by transient, I mean areas where people don't spend a particularly long amount of time, i.e. Washrooms, corridors, nappy changing facilities, changing rooms. These kinds of areas are all areas where people go in, they might spend 10, 15 minutes there, and then they leave. Okay, they're not sat underneath one of these units for 8 hours a day. That's not what these units are designed to do. These units are active cleaning mechanisms, so they should be sited in what we refer to as transient areas. Hope that answers the question. But the risk involved is minute. We're just trying to protect the reputation not only of the business, but also of our partners such as Citron Hygiene, and of course the end user clients as well. Hope that answers the question.
I will add that as we work with any of you for evaluating your on-site needs, we will work together hand in hand with Kazim and Dan's team to ensure that we're placing these units in the most optimal place possible, making it the most effective in each environment that you have. If I can ask a question, Kazim, because that was the only one in the chat, was some feedback we have had is that the system potentially is a duplication of efforts with the investments that the buildings have already done on their HVAC systems.
Okay.
Can you outline why this isn't a duplication and a necessary step?
Good question. One that we get asked regularly on a regular basis. The difference is, first things first, we are also a HVAC company, in case anybody's wondering. We provide HVAC solutions using UV. That's a part of what we do, of course. But obviously, because of COVID, businesses have spent a lot of money and time in their HVAC systems to improve them. Now, this is an air and surface disinfection system. That's the key point here. The fact that no matter how good your HVAC system is, you're not going to be able to continually treat your surfaces. Okay, you can obviously improve airflow, and airflow is treated and it's filtered through, etc. Fantastic. But the ongoing treatment of surfaces is what this unit is able to do, as well as having a little byproduct, if you like, of being able to rid an area of odor, which no matter, again, how good your HVAC system is, a lot of it's going to relate to surface bacteria and surface contaminants, which we do treat, and therefore we get rid of the odors as well. So that's my answer to the question, basically, is the fact that it's an ongoing air and surface disinfection system.
Thanks, Kazim. We got another one. And
sure.
For anybody who lives in Candiac, they dealt with this yesterday. If the power is off for whatever reason, a blackout, will the unit turn itself back on?
No, good question. I presume so. If the power switch has been left on, and the power automatically restarts, then yes, absolutely, yes.
That was any sort of blackout, would there be a problem?
No.
Okay. I don't see any other questions that are coming up in the chat.
There was one with regards to price. I don't know if we tackled that, but just the difference between the power and the price. Would that fluctuate if they went from a AC 20 and the lamp was changed out to go down to an AC 10 or an AC 30? I don't believe it does, but that's a Citron question.
Yeah, I think that was a Citron statement. Yeah.
Oh, it is. Oh,
yeah.
I said. I'm sorry.
J'ai dit que j'allais traduire des questions en français s'il y en a qui sont plus à l'aise de le poser. Je m'offre présentement à traduire des questions en français s'il y en a. Well, I don't think so. I think, Kazim, you did a fantastic job. No questions.
Sorry, I didn't realize I'd gone over, so my apologies to everybody. I didn't want to take up everybody's time. But thank you as far as we're concerned. Again, happy to, if people want to stay on the line, we're happy to sit back and take further questions. Otherwise, have a nice weekend, everybody. When you get to it, I'm a bit ahead of you, so I will get there first. But I'll be probably working late anyway, so yeah, we'll probably finish at the same time. No problem.
So thank you to Kazim and Dan for the presentation. And as always, a huge thank you for all of you for your time today and your business. And for your business, we truly appreciate it. S'il y en a qui veulent rester, vous veulent poser des questions, on peut rester une couple de minutes encore. If anybody wants to stay on, we'll stay on for a few more minutes and answer any questions. But thank you all. Have a great weekend. Bonne fin de semaine. Thank you to all of you.
Bonne fin de semaine. Merci beaucoup.
Thank you.